Hello everyone. We're going to be looking at section 3.4a, increasing and decreasing intervals. So this is kind of where we start taking the derivative and using the information from the derivative. If you remember, when we first talked about derivatives, derivatives stood for instantaneous rate of change. So in other words, they give you the slope on the graph at any given point. If the derivative is positive, that means you've got a positive slope. So in other words, the graph is increasing or going upward at that point. If the derivative is negative, that means the slope is negative, so the graph is going down at that point. If the derivative happens to equal 0, then you would literally have a horizontal tangent. In other words, you have a horizontal line, basically a slope of 0. So the first few questions you'll see in the homework are going to be graphs, sort of like what we have here for number 1. Consider the graph and determine the open intervals on which the function is increasing and on which the function is decreasing. Enter the empty set symbol to indicate the interval is empty. So the empty set symbol right there, you'll find that on the keypad on Hawks. That literally means none. That's the translation for that symbol. It's just a mathematical notation to indicate none. So when they're saying the interval's empty, that means you don't have that type of interval. So if we take a look at this graph, as we move left to right on the graph, here I am down here, the graph's moving upward, 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 kind of almost levels out, but not quite for just a second there, but it keeps going up, 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 up. So this entire graph is increasing. So when we list the intervals down here, we want to list the x values on which the graph is increasing. So you've got these arrows on each end of the graph that indicates the graph keeps going that direction forever. So this whole graph is increasing. So we're going to list that as negative infinity to infinity. We don't have anywhere on this graph as we move left to right where the graph actually goes downward like that. So we do not have a decreasing interval, so that's where the empty set symbol comes in. It's kind of like a 0 with a line through it. Okay, so pretty simple. Let's take a look at another one. Okay, so notice the same directions, just a different type of graph. Alright, on this one, you'll notice as we start on the left, the graph is moving upward here, so we would say this part's increasing. Then it kind of gets to this high point right here at the top. And now it's going back down, so we'd say this is decreasing. Okay, so we want to label that. So what's the x value for that point? Well, it's 1, 2 units to the left of the y-axis. So that point is at the x value negative 2. So we could say this is increasing from negative infinity to negative 2, and likewise decreasing from negative 2 to infinity. Notice at negative 2 itself, the graph sort of levels out. So what we would have there would be what's called a horizontal tangent. If I drew the tangent line right there, trying to draw that straight, I'd have basically a horizontal line there, horizontal tangent at that point. So the slope is literally 0 at that high point of the graph there. Okay, let's go to another one. Alright, so on Hawks, anytime they have a vertical dotted line, notice the blue dotted line going straight up and down here at 1, 2, 3, negative 4. That's called a vertical asymptote. Okay, so I'm just going to label that VA here, vertical asymptote. If you remember in algebra, a vertical asymptote is a line that the graph can never cross. So as we look at this graph, if we're going this way, we can't get past that vertical line there. So we can't go all the way to the left to negative infinity is what I'm saying. So as far as increasing goes, this graph's going upward as we move left to right. But again, it can't go any further to the left than -4. So we would say it's increasing from -4 to infinity. And again, we don't have anywhere on this graph where the graph's going downward like so. So no decreasing interval. So that's going to be, again, our empty set symbol. Alright, how about this one? If you look at this graph, as we start on the left here, the graph's going upward here. So this is going to be increasing. Right here in the middle, it's going back downward. So we'd say that's decreasing. And then it's going back up again. So we've got an increasing interval, a decreasing interval, and then another increasing interval. Whenever there is more than one of the same type of interval, there's two increasing intervals in this case, we separate those in our answer with a comma. So to describe this first interval over here that's increasing, we would say that's going from negative infinity to the x value of this point, which is at -1. Okay, and then just put a comma to go to your next increasing interval. It starts right here. That's at the x value 2, and it keeps going up forever after that. So we would say 2 to infinity. There's only one decreasing interval. It's between -1 and 2. Notice the increasing and decreasing intervals never overlap each other. In other words, a graph can only be doing one thing at a time. It can be increasing, or it can be decreasing, or it could be doing neither one. But it can't be increasing and decreasing at the same time. It's got to be doing one or the other, or neither. Okay, so you'll see some graphical questions like that. Just keep in mind on your answers, the intervals you're listing, you're always listing x values. Okay, you're never listing y values on these answers. All right, after that, we get over into actual functions. So we don't have a graph to look at here. Now, if you remember how to graph from algebra, I guess you could actually graph that function. But we want to make use of derivatives here. There's actually no need to graph this. One thing you may want to remember from algebra is quadratic functions. Notice our biggest exponent right here is a 2, so this is considered a quadratic function. Quadratic functions, their graphs were parabolas, so they either looked like that or they looked like that. Basically, if the coefficient in front of the x squared was positive, it looked like this. If it were negative, on the other hand, then it would be flipped over. Okay? So we kind of remember that from algebra, but again, even if we don't remember that, we can still use calculus to figure out where it's increasing and decreasing. Okay, so right now we have the original function, 2x squared plus 12x plus 14. Derivatives give us instantaneous rate of change, or slope. In other words, it's the derivative that actually tells us increasing or decreasing. So we're going to have to do a derivative to get where we're increasing and decreasing at. But once we have the derivative, how do we know which part to answer for increasing and which part to answer for decreasing? In other words, we've got to have some x value as sort of the dividing line. So if you think about it, if you have a parabola like this is going to be a decreasing part and then an increasing part. So where is this low point at? Okay, so what you want to keep in mind here is there's a horizontal tangent right there at that low point. Okay, so if we can figure out that value, we know the dividing line, if you will. Alright, so how do we get that? Well, again, horizontal tangent is going to be less high or low point in this case, where the graph changes from decreasing to increasing. Okay. So what we need to do is go ahead and take the derivative, and then we'll set it equal to 0. If the derivative equals 0, that means you have a horizontal tangent. Okay, so let's do that. So come down here, f prime of x, we can just use the power rule here. So the derivative of 2x squared is 4x. The derivative of 12x is 12. Of course, the derivative of 14 is 0. Go ahead and set the derivative literally equal to 0. And you can solve that for x. So in this case, negative 4x equals 12. Divide each side by negative 4. 12 over negative 4 is negative 3. So we have a horizontal tangent at negative 3. In other words, if we took negative 3 and plugged it into the derivative for x, we would get 0. Okay, so our answer to step 1, any values of x that correspond to horizontal tangents, negative 3. Alright, so step 2 is back to increasing and decreasing like we did with the graphs. Instead of actually drawing the graph, we'll use a sign chart to indicate the increasing and decreasing intervals. So draw a horizontal line here. That'll be a number line, if you will. This number line goes from negative infinity to positive infinity. Alright, let's place the horizontal tangent on here. So somewhere in between negative infinity and positive infinity, we got a horizontal tangent of negative 3. So in essence, what this does is it separates this function into two intervals. An interval from negative infinity to negative 3, and another interval from negative 3 to positive infinity. Okay, we want to know which interval is increasing, which interval is decreasing. So what we can do is plug a test value into the derivative in each interval. So for negative infinity to negative 3, I can pick any number between negative infinity and negative 3. Let's say we pick negative 4. Likewise, for the other interval, I need to pick something between negative 3 and infinity. I like to pick 0 or 1 when I can, so I'm going to pick 0 here just because it's easy to plug in. And all we need to do is actually plug those into the derivative. Okay, not the original function. The original function is just going to give you a y value. We're looking for the slopes, which is from the derivative. So if we plug negative 4 into the derivative, f prime of negative 4 would be 4 times negative 4 plus 12, which would be negative 16 plus 12, so that's negative 4. All that matters is this is a negative number. So I'm going to put some minus signs here. In other words, this is a decreasing interval because the values are negative. Now again, if you picked any other value in that interval, it would always come out negative. Okay, so again, I picked negative 4. You don't actually have to pick that. You could pick negative 5 or negative 6 or negative 10, whatever you want, as long as it's in that interval. Alright, if we plug in 0 into the derivative, 4 times 0 plus 12 is going to be 12. That's a positive number, so I'm going to put some plus signs here. Okay, so in other words, the slope's positive over there, so we would call this increasing. Alright, good. So now answer our questions. So our increasing interval, that's the right interval over here, goes from -3 to infinity. So write it as an interval. Our decreasing intervals here on the left, it goes between -infinity and -3. And that's it. Alright, what does this actually tell us? This tells us if we saw the graph, you don't have to graph it, but if we saw the graph, say here's -3, our graph is going to be going to the left of -3, it's going to be decreasing, so it's going down, and it's going back up past that. So we've got some parabola that looks something like that. Okay. Now again, it could be, you know, above or below the x-axis, maybe like that. I don't know. I haven't checked that part, but all we're concerned about here is where is it increasing or decreasing. Okay. So that's what the derivatives have told us. Okay, let's do another one. Alright, so this one's a cubic equation. The biggest exponent's a 3. If you remember in algebra, cubic equations can basically look like this, or like, or like that. Basically, each end points a different direction. We're going to do the same thing we did in the previous question. So step 1, horizontal tangents. We need our derivative. So f prime of x is going to be 3x squared plus 12x plus 12. Set that equal to 0 and solve for x. Notice I can factor a 3 out of this. So let's go ahead and do that. And then x squared plus 4x plus 4 actually factors as well. So that'll be x plus 2 times x plus 2. Alright, so when we solve this, remember in basic arithmetic, if you have 0 on one side of an equation, you can break it apart. It's called the zero product property. So you have 0 equal 3, 0 equal x plus 2, and 0 equal x plus 2. Okay, from 0 equal 3, there's no x value to solve for there. So we don't get anything from that. For 0 equal x plus 2, if we just subtract 2 over, x is going to be -2. And then our other equation is the same, so we're actually going to get -2 twice. There's no need to list that twice. In fact, if you try to list it twice, it's going to mark it incorrect. -2 is the same thing as -2. So in step 1, you just have -2 as your horizontal tangent. Alright, and then we'll build our number line to do the increasing and decreasing part. So again, number line goes from -infinity to infinity. We put that horizontal tangent, the x value of that horizontal tangent, on the number line at -2. And we pick something in each interval to plug into the derivative. Okay, so for the left interval, I need something less than -2. Let's say -3. For the right interval, something between -2 and infinity. I'm going to pick 0. Okay, go and actually plug those into the derivative. Again, our derivative's right here. If we plug in -3, let's see if I calculate that, that's going to be Negative 1 times negative 1 is 1 times 3 is 3. It's going to actually come out to be 3. Okay, so all that matters is this is positive. Go ahead and say equal 3 here. Okay, so this is an increasing interval. Alright, if I plug in 0, then I'm going to get 3 times 0 squared plus 12 times 0 plus 12. I'm going to get 12. Okay, so this is also positive. So this is also an increasing interval. So it is possible to have two intervals next to each other that move the same direction. In this case, they're both increasing. Perfectly fine for that to happen. In essence, what it means is the graph almost levels out at the x value negative 2, but it's still increasing on either side. So it would look something like this. It's increasing. At negative 2, it almost levels out, and then past negative 2, it's increasing and increasing again. It's going to be some graph that looks something like that. Again, you don't have to graph it. Alright, so first of all, there's no decreasing interval anywhere. So for decreasing, we can go ahead and put that empty set symbol. Don't have any of those. For increasing, what do I do here? Do I label this as two separate intervals, or should I label it all as one big interval? Well, what it boils down to is this. If negative 2 is in the domain of the function, in other words, can you plug negative 2 into the original function up here and get a number out? If you can do that, it's in the domain. Then we include that point, that value in the interval. Okay. So I don't even have to calculate it. If I plug negative 2 in for x up here in the original function and calculate that, I'm going to get some number. It doesn't matter what it is. Okay. So in this case, we'll say our increasing interval is everywhere. So in other words, I'm not listing two separate intervals. It's all one big interval. The whole thing's increasing. Okay, and I've got one more of these. So it looks similar to the last one. It's a cubic function again, negative 3x cubed. Similar to what we did here in number 6. It was a cubic equation. But the answer is going to work out a little different, and I'll show you that in a second. Again, in number 6 here, one solid increasing interval from negative infinity to infinity. That's actually not going to happen on this one. Okay. But let's go try to work it out in the same fashion. So let's start with our derivative again. So derivative of negative 3x cubed is negative 9x squared. The derivative of negative 9x squared is negative 18x. And derivative of 72x is 72. We're going to set that equal to 0 and solve for x. Notice 9 goes into these coefficients here, so I'm going to go ahead and pull a negative 9 out. It's going to leave me x squared plus 2x excuse me, minus 8. And then x squared plus 2x minus 8 factors. Alright, so we've got to get a positive 2 and a negative 8, so it's got to be plus 4 minus 2. Alright, so when we go to solve, we're going to get 0 equal negative 9, 0 equal x plus 4, and 0 equal x minus 2. So don't get anything from this as there's no x's. We'll get negative 4 for x here, and we'll get positive 2 for x here. So we actually have two horizontal tangents in this particular graph. As far as step 1 goes, you just list them with a comma in between them. There should not be parentheses on step 1. It's just a list of x values. It doesn't matter what order you write them in. So you can either write -4, 2. Again, no parentheses. Hawks accepts that, or if you wanted to write it as 2, -4, Hawks will accept that as well. Doesn't matter what order they're in. It's just, again, a list of x values. All right, and then step 2, the increasing and decreasing part. So we've got to do our number line again, -infinity to infinity. Since we have 2 horizontal tangents this time, we're going to list both of them on this number line. Now they need to be in order. So -4 should come before +2. And we're moving from smaller numbers to bigger numbers as we move left to right. And when we do that, notice now we have 3 distinct intervals. We've got -infinity to -4, we've got -4 to 2, and we've got 2 to infinity. So 3 distinct intervals. That's fine. All it means is you're going to have to pick 3 different test values to plug into the derivative. So something from each interval. Okay, so for the left over here, I need something between -infinity and -4. Let's say -5. For the middle, I need something between -4 and 2. I'm going to pick 0. And for the right over here, you need something bigger than 2, so I'm going to pick 3. And again, here's our derivative. You can plug them into that. Okay, so I'm going to get my calculator here and plug in -5. I get -63 when I plug that in. So this is negative, so this is a decreasing interval. When I plug in 0, I'm going to get 72. Okay, that's positive, so that's an increasing interval. And then over here, if we plug in 3, let's see, that's going to be also -63. Okay, so this one's also negative, so that's also a decreasing interval. Alright, so there's one increasing interval in the middle between -4 and 2. There's 2 decreasing intervals, one on the far left from -infinity to -4, and another one on the far right from 2 to infinity. Again, just put a comma in between separate intervals. And there we go. Alright, so in essence, all we've done in this section is figured out what horizontal tangents are. That's basically when the slope is 0. In other words, it's where you take the derivative, set it equals 0, and solve for x. And we've figured out where we have increasing and decreasing intervals. Increasing intervals means the slope's positive. In other words, the graph moves upward as you move left to right. Decreasing intervals means the slope is negative. It means the graph moves downward as you move left to right.